Ever get this feeling like the universe is kind of winking at us using math? Not just something we made up, but like built into reality itself. You wanted a deep dive on this, so get ready. We're going deep on how math shapes the universe.
It's a trip, right? We think math, we think tools, but what if it's more like the universe's language, a truth that's bigger than us here on Earth?
Right. Like aliens, if we ever wanted to chat them up, what could we even use that makes sense? Across galaxies, different life forms, the whole shebang.
Well, some folks are saying prime numbers.
Prime numbers, hold on. Those are the ones only divisible by 1 in themselves, right? Like 2, 3, 5, 7, that crew.
Bingo. And that's what makes them special. Not made up, it's just true here. Alpha Centauri, wherever. Neil deGrasse Tyson, the astrophysicist dude, he's got this idea, right? Send pulses out 2, then 3, then 5.
Like a cosmic Morse code.
Kinda. Any civilization smart enough to hear us would probably get that we're talking primes on purpose.
Hey, brainy life forms over here. But with more math?
Exactly. It's like saying maybe, just maybe, everyone's working with the same universal building blocks, even if life looks totally different out there.
Wild. But also, those same prime numbers, they're keeping our stuff safe right here, right? Online and all that.
Boom. See, that's how something so huge, like talking to aliens, is also in our digital lives every day. It's called cryptography.
Okay, hold up cryptography. Break that down for me for the non-hacker folks out there.
Think of it like making a puzzle that's crazy easy to solve one way, but trying to go backwards. Near impossible. That's what keeps our online stuff safe, and prime numbers are the backbone of it.
So, like, if someone's trying to hack you, they're stuck doing prime number Sudoku or something.
Basically, yeah. It gets way more complex, but that's the gist. Crazy hard to crack, keeps your data safe, and it all comes back to these numbers that are just true.
Mind officially blown. Makes that whole math is the universe's language thing even more real. But the article you sent, it gets even weirder. Like, math isn't just a tool, it's how reality's put together at the base level, right?
Think about physics, gravity, how things move, tiny particles, the whole deal. And it's all equations, right? Math equations.
And it's not just physics, is it?
Nope. Chemistry, biology, even music, art. There's patterns, ratios, harmony. It's like the universe is humming a mathematical tune and we're just starting to hear it.
And talking about mind-blowing stuff, what's this I hear about AI getting in on the math game? We got robot mathematicians now. Is my calculator going to ask for a raise?
Not quite robots taking over. Yeah, at least. But yeah, AI is changing how we do math big time. And one of the big players is DeepMind.
DeepMind. Wait, they made that AI that crushed everyone at Go, right? That super complicated strategy game.
Yep, that's them. But they're doing way more than games now. They're making AI that can look at tons of math data, finding patterns, making connections that'd take us humans ages to figure out, maybe even centuries.
So, like, instead of replacing mathematicians, AI is more like giving them a serious upgrade.
Totally. Imagine, right, having a whole team of, like, superpowered research assistants, crunching numbers day and night, spotting things we might miss. And it's already doing crazy stuff. Remember the article talked about DeepMind and that math Olympiad?
Oh, yeah, like the computer whiz kid taking on the mathletes.
Exactly. They built this AI to tackle those super hard Olympiad problems. And get this, it did crazy well, like silver medalist level.
Seriously?
Yeah, but here's the thing that really gets me. They didn't, like, program it with the answers or strategies, right? They just gave it a ton of math knowledge and basically let it loose.
So it taught itself how to be a math champ.
Pretty much. It's
Yeah.
using pattern recognition, deduction, the whole 9 yards.
Okay, that's both really awesome and kind of freaking me out a little, not gonna lie.
It definitely makes you think, right, about what intelligence really is, whether it's us or AI doing the thinking. But for now, the important thing is it's a tool. A powerful one, yeah, but a tool to help us understand math even better.
All right, I need a sec to process this AI stuff. It's a lot, maybe something a little more, I don't know, human-sized for a minute.
Sure, what did you have in mind?
Well, the article mentioned this whole thing about, get this, Wordle, and how it connects to math.
Wordle? You mean the 5-letter word game? How does that even relate?
I know, right? Sounds crazy. But it's about this thing called information theory. Honestly, when I first read it, I was like, whoa, too much brain power required.
It's not as complicated as it sounds. Basically, information theory is about measuring information, like how much meaning's in a message, how well it gets across, even how surprising something is. And turns out it applies to how we play Wordle.
Okay, now I gotta know. How does knowing about information theory make me a Wordle master?
So think about it. Every guess you make in Wordle, it gives you information, right? But some guesses are better than others, like A word with common letters, vowels especially, or even just in the right places, those give you more clues on average, even if they're not the answer.
So a well-placed A is more valuable than a Q, like information-wise, not just in the game.
Exactly. It's all about reducing uncertainty. Each guess should ideally cut down the possible answers as much as possible. And that's where this thing called entropy comes in, from a guy named Claude Shannon.
Entropy, like in physics.
Same word, different use here. In information theory, it's basically a way to measure uncertainty. High entropy means lots of possibilities. Low entropy means things are more certain. So in Wordle, you're trying to lower the entropy with each guess, getting closer to the answer.
So those little green and yellow squares, they're not just satisfying, they're like little entropy destroyers.
Mhm.
That is way cooler than I thought. Mind blown that Wordle's got all this math behind it.
It just goes to show you math is everywhere, even in places you wouldn't expect. Speaking of unexpected, we're going to talk about pi.
Pi. You mean 3.14159 dash whatever keeps going. The circle thing.
Yeah.
What's so special? We already know what it is, right?
Sure, everyone knows pi from circles, but here's the wild part. That number pops up in the weirdest places in math, places that have nothing to do with circles at all.
Wait, seriously?
Yeah.
Like what? Give me an example.
Okay, get this. You know infinite series. Like if you add up fractions forever, there's this one, starts with 1, then minus 1/3, plus 1/5, minus 1/7, and so on. Crazy thing is, that infinite sum, it eventually gets closer and closer to pi divided by 4.
Hold up. You're telling me adding fractions, which seem as far from circles as you can get, they somehow make pi. What?
It's wild, right? It's like pi is this hidden ingredient in all sorts of math recipes. You just got to know where to look.
Okay, that's twice. Now you've blown my mind. First prime number is keeping the internet safe. Now pi and my fractions. What else you got for me?
Well, since you're on a roll with these unexpected connections, let's dive into fractals. Those are fun.
Fractals. Those are those crazy, detailed, never-ending patterns. Right. Always thought they looked cool, but never understood what the big deal was.
You got it. They're infinitely complex, but come from these really simple rules. It's like proof that beauty can come from elegance, mathematically speaking. Like, take the Sierpinski triangle. Ever heard of that?
Sierpinski. Rings a bell. Is that the one? Kind of looks like a triangle made of smaller triangles.
Bingo. Imagine you start with a plain old triangle. Then you split it into 4 smaller ones, same shape, and you erase the middle one. Then you do that again to all the little triangles left, and again, forever. That's the Sierpinski triangle. Crazy complex, but the rule is dead simple.
It's like a recipe for infinite beauty or something. But are fractals just pretty pictures? Or are they actually good for something?
Oh, fractals are way more than just pretty pictures. Turns out they're kind of everywhere in nature.
Wait, really? Like what? I need to see this to believe it, I think.
All right, picture a coastline, right? It's not just a straight line. It's all jagged, little bays and inlets and stuff.
Yeah, okay.
So you zoom in on a map of that coastline, what happens? Those little details, they kind of look like the whole coastline itself, just smaller.
Oh, right. It's like the same shape, but repeating over and over.
That's the fractal thing. Self-similarity, they call it. And it's not just coastlines either. Mountains, you know how they have peaks and valleys, but then those break down into smaller ones?
Okay, yeah, I'm seeing it.
Snowflakes, they're like fractal superstars. Even blood vessels, the way they branch out in our bodies, it's all kind of fractally.
So nature's out here speaking math, and I didn't even know it. That's kind of poetic when you think about it.
Right. It's like maybe math isn't something humans just made up, you know? Maybe it's baked into the universe from the tiniest thing to like galaxies far away, all following these rules.
This whole conversation's got me looking at things differently, I'm not going to lie. All this prime number stuff, AI learning to math better than us.
It's a lot, right?
It is. In a good way, though. Like there's more going on than I ever realized, you know?
That's the beauty of it, though, isn't it? Math makes you question things, see things new ways, makes these connections you wouldn't believe.
It's funny because back in school, math was always one of those things. You either loved it or you were like, please, no more equations.
Oh, yeah, I remember those days.
I was definitely more on the dreading homework side of things. But the article mentioned something about math being good for your brain, even if you're not like a math whiz.
Absolutely. Even just thinking about math stuff on a small scale, it helps with your thinking in general, problem solving, seeing patterns, all that good stuff.
So besides maybe helping us figure out the universe, it can just help us figure out like Tuesday afternoon.
Exactly. It's a toolkit for life, not just for like scientists or whatever.
I dig it.
Yeah.
And this whole conversation, it's been full of those moments, Like when you explained how prime numbers keep the internet safe, or that Wordle thing with the information theory.
Yeah.
Those aha moments, that's the good stuff.
Right, that's what makes this whole exploration worthwhile, that little spark when you grasp something new or see something familiar in a whole new light.
Like upgrading your brain to HD or something.
Yeah.
Or maybe realizing we're all just living in a giant fractal and didn't know it.
Maybe we are, but hey, that's something to ponder, right? So, for everyone listening, next time you're checking out a cool leaf pattern or looking up at the stars, remember, you're seeing the universe's language in action.
Beautifully said. And with that, we'll wrap up this deep dive. Hope you're feeling a little more mathematically minded out there, folks. Keep exploring, keep asking those big questions, and we'll catch you on the next one.